So now let's move into Kepler's second law. Kepler's second law says that the straight line joining a planet and the sun will sweep out an equal area in space in equal intervals of time. So what does that mean? It means that if I'm looking here at region B and the planet moves from point 1 to point 2 in a time t, it sweeps out some area here shaded in yellow. And the area of that, the amount of pizza in that slice, is the same area, same amount of pizza as there is in slice A if it takes the same amount of time t to go from point 3 to point 4. So if they have this equal times sweeping from 1 to 2 as from 3 to 4, then the area swept out by the line connecting the sun to the planet is the same in region B as it is in region A. This leads us to a poll question. If the comet shown in this orbit takes 1 year to move from point 1 to point 2 and 1 year to move from point 3 to point 4, then how must the green area compare to the red area? If the orbits from 1 to 2 and from 3 to 4 take equal time, then by Kepler's second law, equal time means equal area. So the answer here is B. Okay, let's look at a slightly different situation. Let's say that it takes the comet 2 years to move from point 1 to point 2 and 1 year to move from point 3 to point 4. In that case, how does the green area compare to the red area? So we have a longer time, so therefore we have a larger area swept out. So if we think about how Kepler's second law affects the speed of a planet, it's helpful to consider that if we look back at our original diagram, when our planet is moving from point 1 to point 2, it's going over a longer distance than when it's going from point 3 to point 4. But in both cases, those paths take the same amount of time to complete. So take a minute to think about if you have a longer distance to go in the same amount of time in area B, then does that mean the speed is faster or slower than in area A? Now hold that thought and let's go to our third poll question here. And now I want to ask you, at which point in the orbit shown here would the comet's speed be the largest? So the answer is A, that the comet's speed is highest when it's at its perihelion point, when it's at the nearest point to the star. And that's because it has to sweep out a relatively large area in a given amount of time here. It has to travel a long distance in a short time. Whereas when it's at the farthest end, the aphelion point, the area that it sweeps out is a narrow but long wedge with the same area as the fat and short wedge, but it goes a small distance in that amount of time when it's at E. So it's moving very slowly out here at aphelion and moving very quickly here at perihelion.